Today we're going to continue the review of Java Server Faces as part of the Java Enterprise Edition module. We're going to consider the web tier, which is the front part, the customer-facing part of the enterprise application. And the other bit we're going to consider today are JSF validators and converters. So in the previous lecture, we looked at Java Enterprise Edition as a vehicle for describing enterprise applications in general. So it's a framework that allows us to build large and scalable applications that have got a built-in approach to security and reliability, so that it's all done in a very consistent way across the application. We also looked at a simple JSF example, and what we're going to do is add a bit more information about the lifecycle for JSF. Remember, JSF is a server-side component-based framework that allows us to build Java-based web applications. We have used it previously as a web application interface, but of course we can make use of it on a bigger scale in an enterprise application. And what JSF provides for us is an API. That API will facilitate the plug-in and unplug of our components. So we write components to fit that API, and then the JSF framework will make use of our components because they match the interfaces that the framework has specified. So we can do things like not only build our components and plug them in, but then we can leave it to the framework to manage the state of these components, to create them when they are needed, to destroy them when they're no longer needed, and to manage their existence across the various scopes. We can write event handlers, and they will be used at the appropriate time in the life cycle because they will fit with the API for that particular event handler. And we'll see an example of that with validation and conversion. We can also define page navigation, and we saw an example of that in the previous lecture where we can set a number of navigation rules. And by doing that, we're separating the navigation around the system from the logic that is used when we're interacting with a particular page. And it allows us, because of that separation, to change the order of page navigation without having to go in and change Java code. There are also tag libraries that allow us to add components onto web pages, and we saw some examples of that in the previous project last week, where we defined some XML namespaces, and those namespaces were referencing tag libraries. We're able then to make use of the tags that are defined in those libraries. For example, h:form. There's one of the tags that's in one of the libraries, and we'll see some more of those tags today. So a typical Java Server Faces application includes web pages. It will also include tag libraries and managed beans. Now those web pages will have user interface components, and the XHTML files, which are called facelets, they will lay out those UI components. Often, those components will need to be bound to properties in managed beans, and we'll use the expression language to do that. As I've mentioned already, the tag libraries are used for essentially selecting the tags that we want, making use of the ones that we want that are predefined and therefore standard. And that's a great benefit, having these standard libraries. The managed beans are lightweight, which means 100% Java, and they are managed by the container. They are essentially POJOs. There's nothing particularly special about them, just plain old Java objects. As we mentioned last week, they're sometimes known as backing beans because they sit behind or at the back of the web pages and will serve to store data and also provide information for the various views that are expressed in the facelets. We'll also have a web deployment descriptor, web.xml, and this file allows us to specify settings for our application when it gets deployed to the server. And we might see some examples of that over the coming weeks. We're also able to apply or define one or more application configuration files, typically faces-config.xml. Again, this is where we are able to do some setup configuration of our application specific to the Faces environment. And one of the things that we saw last week for that were the navigation rules. We're also able to do other configuration too. The custom objects that we can write, in other words, our very own classes that will be used by the managed beans. So we can write just ordinary Java objects or write the classes for those ordinary Java objects and then use the managed beans to instantiate, invoke, destroy, and so on. We don't have to worry too much about those kinds of things in terms of the framework because they are essentially helper classes. We write them, we use them, and it's controlled from the managed beans. And it's the framework that will invoke the managed bean and set that running with one of its methods, and that method will then make use of these custom classes. There are other classes that we write that are definitely part of the framework, validators and converters and listeners. And today we'll see some examples of validators and converters. Now, one of the very great benefits, in my opinion, of JSF is that we get this very clean separation of behavior from presentation. In the previous offering, in terms of web applications, we used servlets and Java server pages. And that was, I think, a step in the right direction. But although we were encouraged to have view components in the JSPs and model components in the servlets and helper classes and so on, there was nothing to stop us from writing model code, business logic, inside the views. You can't do that in JSF in quite the same way. You can do it with the expression language. Typically what's happening though is that you're using the expression language to bind to a method or a property in the backing bean, and then all the logic is in the backing bean or in other classes that the backing bean uses. You shouldn't do it in the XHTML files. And therefore the business logic is very cleanly separated from the presentation code. It also means then that we're able to provide this fine-grained separation. In other words, we can have very small components that do very specific things and then reuse those components in all kinds of different places within our applications. Now, the expression language is quite a simple thing. It allows us to access at runtime, hence dynamically, the data that are in the Java Bean components. For example, we could have an H2 tag with some fixed text, hello, comma, space, and then we want some dynamically generated data that we want to pull out of a property in a bean. And so we can use the expression language here, the hash, open brace, and then the name of the bean, dot the name of the property, close brace. In the example last week, we showed that as an output text component in the XHTML file. And that probably is a better way of doing it because the output text element will then be rendered by the web browser or the mobile device in a way that is specific and appropriate for that display mechanism. So the expression language then is used to do things like defer evaluating expressions or evaluate them immediately, setting and getting data in managed beans. We saw examples of that last week. We can also invoke methods in managed beans. These typically will be action methods. We'll also see examples of other ways in which we can invoke methods for other purposes during the course of this lecture. And we can dynamically perform arithmetic operations. Usually, an expression language value will be determined after certain other things have happened in the lifecycle. For example, conversion and validation will take place first. And thus, because we would normally want these things to go through the full lifecycle, we will defer evaluation. And hence we would make use of the hash in front of the two braces. If we want to evaluate these without passing through the normal lifecycle, then we would use a dollar instead of a hash. And that means that the expression will be evaluated immediately and not subject to the normal conversion and validation parts of the life cycle. Managed beans will be used, as we've seen already, by the facelets, because the facelets will have UI components that are bound to managed bean properties. Therefore, an application will have at least one managed bean. But it's fine to have more than one managed bean. In fact, it's probably a good idea to keep the managed beans very focused on one task. Therefore, it is quite possible that you will have multiple managed beans being used on the same facelets page. So a managed bean is created with a default constructor, which is a constructor with no parameters. And then there are a number of properties. Remember, a property has three parts. The field, which is the variable declared inside the bean, with corresponding set and get methods. We can also have methods that perform specific functions for that component, such as validation, and we'll see examples of that in a bit. As well as being able to do things like validating data that we receive from an input component, we might also want to handle events that are fired by a UI component. For example, an on-change event. As the user types information, it might be that we want to validate what is being typed as it is being typed. And there are certain events, such as on-change, that will fire, and we can register handlers for that. We can also generate values for UI output components and determine the outcome of an action. Now, an action is what happens when the user clicks on a command button. And there is an attribute, as I have mentioned already, there's an attribute in the command button called action that can be linked to a method. We've seen an example where the action equals and then the name of the next facelet that will be displayed. But instead of doing that, we can link it to an action method in the backing bean. That method will execute. So for example, it might be that once all the set methods have been called to pass data from the facelets view into the backing bean, the action method can then execute so that it can use those values that it's just received from the user to interact with the database, pull back values from the database, and then use those values to display the next view. So those are the kinds of things that we might want to do with action methods. Now, we've got three major stages when writing our applications. Write the managed beans, create web pages using UI components from the defined tag libraries, and also defining page navigation. In your opinion, in what order should these activities take place? Any or all? No order? A fixed order? Doesn't really matter, so long as you get the job done. It might be, if you're working in a large team, and that's very possible since you're in an enterprise application environment, that you will have dedicated teams. You might have a user interface team. You might have a business logic team. You might have an enterprise information team. It could be, therefore, that all three teams will be working on the same application at the same time. Therefore, you'll need to manage that project fairly carefully to ensure that communication doesn't break down, that everybody knows what should be done. And so you might find that one team will be writing backing beans at the same time as another team is writing the facelets. So long as you agree on the names of the properties in the backing beans, for example, then the two activities can proceed side by side. So in a way, it's a bit of a trick question, but it is something you need to think about, especially if you're a fairly small team and maybe you're going to do one thing at a time. I've been promising validation and conversion. Let's get stuck into that. The life cycle, as we know, will begin with the request being submitted by the web browser when the user clicks a submit button. That request will carry with it any form data. That form data will then be put into a component tree that has been built by the control servlet. So the control servlet examines the view that has just been submitted. We'll build a component tree to represent that structure and then use the request data to populate the various components within that tree. Then, and this is the important bit, it will perform conversions, and if all the conversions work fine, it will then perform validations. Then if everything is valid, the managed beans, the backing beans, will be updated with the values that are in the component tree, because now we know that those values have been converted to the correct types and contain valid values, and therefore it's safe to put them into the managed beans. Other methods, such as action methods, could then be called, and at some point it's time to render the response back to the web browser. If everything is valid, there have been no exceptions and so on, then we can build the component tree for the next view, take values from the backing beans and put them into that component tree, and then use that component tree to populate the UI components in the next view, send that view off to the web browser, and then save any state that needs to be saved. For example, if we've got some session beans, then those session beans must be preserved between requests, and that's what the session scope is used for. Later, when another request comes in, as well as using form data to populate the component tree, it will also make use of the state that has been saved in the session scope that can also put information into that component tree. So that's the life cycle, and what we're going to focus on now is this thing about conversion and validation. Now, there are standard converters. These are necessary because every value that is typed into an HTML form will be passed using the hypertext transfer protocol, which is a string-based protocol. Therefore, all parameter values arrive at the web server as strings, even if they represent Boolean values or integers or calendar values. They will arrive as strings. Before we can use them in our Java programs, we need to convert those into strongly typed Java objects. Later, when we want to render the response, they have to go back to the web browser as strings. So again, a second conversion will take place where we go from the strongly typed Java object back into string representation ready for display in the HTML. That's the job of a converter, to take a string and convert it to the appropriate Java object, and to take a Java object and convert it back into a string. Two functions. To some extent we are assisted because there are some standard conversions that will take place automatically. Int values will automatically be converted from the strings to integers. If there's a form data that represents maybe a person's age, then that string will be converted using integer.parseInt. But as we know from our work in Java before, that could throw an exception. We can get other kinds of exceptions that occur. Those are the kinds of things that will cause the conversion to fail. And if the conversion fails, the entire life cycle is aborted, and the original view is rendered again with some kind of message. We'll get automatic conversion of the primitive data types, which is determined by the property type in the managed bean. So in the facelet, when you link a UI component to a property in a bean, we know that the set method will be called for that property, and it requires a parameter. If that property is of type int, then the parameter will be of type int. And so the standard converter will just take a look at that property and say, oh, I need an int, and will attempt to convert the string that it's holding into an int. If it fails, the conversion has failed, therefore the life cycle is aborted and an error message is sent back to the original view. We also can make use of some standard converters for things that are not done automatically, and we can write our own custom converters. Now, the thing about conversion is if it goes wrong, there's got to be an error message that will help the user, and true to form, the standard error messages do not help the user. Take a look at this one as an example. That is what the user will see if we do not provide our own converter error messages. To avoid that kind of error message, we can provide on the input text element an attribute called converter message. And there we type some helpful user-focused message that will help the user to determine what has gone wrong. You can also see that we have an attribute here called required, which, if set to true, the user must provide a value. If the user does not provide a value, that also will cause an error message. And the required message is the text that will be displayed. Otherwise, we get some kind of standard thing, and we don't like the standard messages because they're not very user-focused. So we have some JSF converters. The first thing that must be true for us to be able to use these standard converters is that the UI component must be bound to a property in a backing bean. And then we can use a standard converter tag, such as convert date and time or convert number. We can use a converter tag to specify a custom converter, or we can use a converter attribute, again, to specify a custom converter class. So those are the three ways that we can do it. Here's an example. We've got an input text, ID equals DOB, title, date of birth, so thinking about some accessibility things here. Value equals, so we're binding this to a property in a bean. Required, with a required message, converter message if the conversion fails, and we can specify in this example a maximum length. These are all attributes. Up until now, what we've done is just terminated the input text element with the usual slash and then the greater than sign. But we're not doing that this time. So we're going to have a corresponding end input text tag. And between the input text tag and its corresponding end tag, we are nesting another tag. That tag is convert date time. The prefix is F. And when you look at the example code that you can download for this lecture, you'll see the XML namespace that has been given this label. So the convert date time takes a type, can be date, can be time, can be date time, and a pattern. So here we're going to have 2 digits for day, slash 2 digits for month, slash 4 digits for year. And that defines the requirements for conversion. So if the user types 03/07/2006, that will convert according to this pattern into a date object, no problem. But if the user types something else, like hyphen or dot instead of a slash, that will not convert, and so we get an error message. The error message, of course, will then be that converter message that is being defined as an attribute on the element. Instead of a standard tag, we might want to make use of a custom converter. The custom converter is a class that we write. As part of writing that class, we will give it a name. And that name is what we use to identify in this converter tag the ID for that converter. So F:converter, converter ID equals, and then in double quotes, the name of that converter. So this is associated, as we shall see in a few moments, with a particular class. Therefore, the control servlet will create an instance of that converter class and then call the appropriate method for performing the conversion. In this case, it's going to take a string and convert it to an object. So it will call the method that does that particular conversion. Something very similar, but this time we're not using a converter tag. We're using a converter attribute. So this is an attribute that is nested inside the definition of the tag, and we still use the converter ID, and it will call the same method. It will work in exactly the same way as the converter tag. So we'll take a look now at the code that does this. It's available on Blackboard. You can see in this example that we're using the third form of conversion, where the tag has got a converter attribute that identifies calendar converter. Over here in the source code, I've put it in the managed beans. You don't have to. You can put that in any package that you want. You might, for example, have a converter package, because maybe you've got lots of converters that you want to store in one place. If we take a look in there, we notice a few things. For example, on line 13, we use an annotation to define that this class is a faces converter. Value equals, and that's where we specify the name, the ID for this converter. Now I've just gone with the default. If you don't specify a value, then the default is take the class name and replace the first character with a lowercase equivalent. So I could call that my converter or my date converter, whatever I want. But whatever name I specify there, that's what we use here. The other thing that we need to note is on the next line, as well as declaring this to be a public class, we must also specify that it implements the converter interface, because we've said that this class is a faces converter. Therefore, it must implement that interface, and the interface defines two methods. The first method is getAsObject. So that will take a parameter, which is a string, and attempt to convert that string into an object of the appropriate type. Now we know that this is a calendar converter, therefore we expect the string to convert into a calendar object. So we'll write the code that will do that. We'll take this string and we will use it here, new value. Let's take a look just up here for a moment at the constructor method. I know for this constructor method that I will want to make use of a simple date format, because I'm going to take a string and convert it into a date. In the constructor method, I'm creating that simple date format object with the desired pattern. On line 21, I'm also setting it to be not lenient. If I left it as lenient, which is the default, then if I were to put in a date such as the 32nd of December 2017, because it is lenient, it will say, right, there isn't a 32nd, but that's one day more than the 31st. So the 32nd of December 2017 will actually come back as the 1st of January 2018. Now I don't want that in my application, so I've decided to make lenient false. And now 32nd of December 2017 will fail. With that formatter set up, in the method getAsObject, I can make use of it. I can use that simple date format object to parse the string that is passed as the parameter, and that will give me a date object. Now on the line before, I've just set up a default calendar instance which has got the current time, but I don't want the current time. I want the time that was passed as a parameter. So I'm going to call the set method here and pass the date object that sdf.parse will give me, and that will change the date and time of that calendar object to the one that I've just converted from the string. I've now got a calendar object with the correct date and time values, and therefore I can return it. If there are no problems at all, then this method finishes and returns that calendar object. On the other hand, we might get a parse exception. And if that happens, I'm going to throw a new converter exception, and it's that exception that will cause the lifecycle to abort, and the error handling of the framework will kick in and display an appropriate error message. What message will be displayed? Well, if I haven't got a converter message, it will be the standard message, but I don't want the standard message. I'm going to put my converter message in there. Please enter a date in the form dd/mm/yyyy. So there's an example of input conversion. The corresponding method is take the object and convert it back into a string. This time the parameter is of type object. Now because it's of type object, I've got to verify first of all that it is not null, also that this object is an instance of the calendar class. If both of those are true, then I can attempt to convert it to a string. If one of those is not true, then I have to decide what I'm going to do. Now I've got to return a string or throw an exception. Wherever possible, return a string, because exceptions cause things to terminate. So what I've decided here is if the value is a null value, then I'm going to return an empty string. So the date will just display, you'll have a label date : space and then nothing. But at least it hasn't broken the application, nor has it returned an error message. Now it might be in some situations you want to return an error message, in which case you'll need to set that up. If the value is an instance of a calendar object, then I can convert it, again using the simple date format, from a date object, which is what getTime gives me, to a string, and then return that string. Otherwise, I've got a problem. and I want to report that problem. And the way that I do that is to create a faces message object. So I've got a string, which is my message detail, unexpected type, get some extra information there. That's the string that I want to display. I then create a new faces message object with this message and also that detail. Then in the faces context, which is this application, I'm going to get the current instance and add a message. The value of this first parameter, which is null, that's going to be the ID. I'm not going to make use of that in this particular example. And then a message. But if we provide an ID, which will typically be this UI component that's passed as a parameter, we could then have that message related specifically to that one component. And we can make use of that later on when we want to display error messages right next to the component that has caused the problem. Having set up that message, I then can throw the converter exception that holds that message. Now all of these messages will get put into a queue, and when the lifecycle aborts and the original view is displayed, then any messages in that queue will also be displayed. Let's take a look at validators now. We do have some standard validation, which will use these tags. I'm not going to talk about all of them, but you can see, for example, we can validate doubles for a range, long values, also int values for a range. We can also validate for length based on the number of characters, and we can validate using regular expressions. It's very similar in terms of approach for as for converters. So we could have a validator message, and we can nest a validator tag specifying the various attributes. So for example, if we're validating for range, we'll have a minimum and a maximum attribute with some values. And this tag will automatically check the value that's been typed by the user to make sure that it's in between those limits. We can also write our own custom validators in one of two ways. We can put a validator method inside one of our backing beans, or we can write our own validator bean. If we take a look at the first one, in the input text element, we've got a validator attribute. And we're specifying, we're binding it to a specific method. That method will be invoked by the lifecycle, the control servlet, when it's time to do the validation. We don't use brackets for these validator methods. There's no need to use brackets there, because the framework knows that this is a method call, and therefore will automatically put the method in there and provide the necessary parameters, as we shall see a bit later. We can also use a validator tag, and again, validator ID equals, just like with a converter, we're specifying the ID that has been assigned to a validator bean. And we can see examples of that in our code. First of all, in the user backing bean, right down at the bottom, we've got a validate first name. It must have this interface. So that list of parameters, it must be able to throw a validator exception, and it must return void. And what we'll do is take this object, which is the value we are going to validate, and typecast it to the appropriate type. Don't forget that conversion will already have been done. So if we get to validation, we know it's okay to convert it to the appropriate type. And then check it, do our validation. Now in this very silly example, your name is not allowed to be Jimmy. Name to check dot equals ignore case Jimmy, that's a problem. So set up a message and throw a validator exception passing a new faces message object. So that's fairly straightforward. And you can have one of those methods, one of these validator methods, for each UI component that you want to validate. And that has the advantage of making each validation method very small, very focused. It only validates one thing. On the other hand, it means that you might well have your validation methods scattered across lots of different beans. Therefore, you might want to make use of a validator bean, in which case you'll write your public class, having first put in an annotation to say that this is a faces validator, along with the ID that is to be used in the facelet. It must implement the validator interface, and that requires one method, validate, with actually exactly the same interface as for your validator method that's nested in the backing bean. However, this time, this is one method that could actually be called upon to validate all kinds of different UI component values. Therefore, we'll need some kind of selection to work out, first of all, what kind of component am I supposed to be validating here. So the UI component parameter, we get the ID, check to see if it's last name or if it's something else, and then perform the appropriate validation. We've got one place to look for all our validation, but it's rather a big method. And of course we can make it smaller by using other methods and calling those methods and so on. But essentially we've got this rather large validation method to look at. And so that's as much as really as we're going to talk about for JSF. We'll move on later to go to other components within the Java Enterprise Edition framework.